Hello everyone, let's continue the session of group 17 elements. So today we will see first oxidation stage. So normally we know halogens exhibit -1 oxidation state, and this is purely restricted only in the case of fluorine. So fluorine is the first halogen. So fluorine can exhibit only -1 oxidation state. Fluorine exhibit only -1 oxidation state. And -1 is the common oxidation state of halogens. So that means all halogens can exhibit this -1 oxidation state. But halogens other than fluorine, iodine, bromine and chlorine, they can exhibit some positive oxidation states too. That is +1, then +3, +5 and even up to +7 they can show. So please note down, generally oxidation state of halogen is -1. Since fluorine is the highest electronegative element, it won't show the other positive oxidation state, but other halogens can show positive oxidation state. And this positive oxidation state, formation of this positive higher oxidation state could be explained by the electronic configuration of halogens. Okay, so halogens, normally we know the outer electronic configuration of halogen is Ns2Np5. Ns2Np5. So we can represent the ground state electronic configuration of halogens. Ground state. So Ns consists of 2 electrons and Np orbital, which consists of 5 electrons, can be represented in this manner. And what happened when it moving to the first excited state? The Ns electron will remain same, but here in this Np orbital, one of the electron from this second p orbital will migrate to the Nd orbital. That means the arrangement of electrons will turns like this. Okay, arrangement of electrons will turn like this. And since here in this ground state, since it contains only one unpaired electron, since it contains here only one unpaired electron, so in this case, except fluorine, other than fluorine, the other halogens can exhibit +1 oxidation state. Okay, due to the presence of a single unpaired electron in the ground state, the halogens other than fluorine can exhibit +1 oxidation state. But in the first excited state, we can see here 3 unpaired electrons are there. By the excitation of electrons present in the Np to the Nd, and because of these excitation, the halogens will exhibit +3 oxidation state. So if a question asked you to prove why halogens exhibit +3, +5, means you have to draw this orbitals and explain this. Okay. And then in the second excited state, what happened means Ns electron remains same, but this Np electron, again this first orbital electrons which get excited to the second Nd orbital. That means the arrangement will be like this. So we will get total 5 unpaired electrons. So in this case, halogens exhibit +5 oxidation state. Okay. Now the third excited state. Here the paired electron which present in this Ns orbital also undergo excitation, and here also it becomes single electron, and that electron also excited to the Nd orbital. Now total 7 unpaired electron, and in this case halogens exhibit +7 oxidation state. So this is the explanation for the higher positive oxidation state of halogen that can be explained with the help of electronic configuration. Okay, so now other speciality of halogen. These all are coming under the chemical properties of halogens. So other important property of halogen, they can act as oxidizing agent. Halogens can act as oxidizing agent. So among this entire halogens, fluorine is the strongest oxidizing agent. Okay, so which is the strongest oxidizing agent among halogens? That is fluorine. Okay, and halogens can oxidize other species, and also halogens can oxidize other halogens also. That means fluorine can oxidize all other halogens. The general fact is that one halogen atom can oxidize other halogens with greater atomic number. So with respect to fluorine, this chlorine, bromine and iodine all exhibit greater atomic number. So fluorine can oxidize all those halogens. So that we can see fluorine can oxidize halogen, then 2x minus will turns to x2, so minus 1 to 0, here oxidation takes place. This X can be here chlorine, bromine and iodine, because all these three exhibit greater atomic number compared to this fluorine. But coming to the chlorine, chlorine cannot oxidize fluorine because atomic number of fluorine is less than chlorine, but chlorine can oxidize bromine and iodine. So that is the reaction is given here. But what about the case of bromine? So with respect to bromine, only one halogen is left. So bromine can oxidize only one halogen, that is iodine. So we can directly write the reaction Br2 plus 2I minus gives to Br minus plus I2. Okay, so please note down the oxidation reactions of halogen. They can act as oxidizing agent where fluorine is the powerful oxidizing agent, and they can oxidize other species and also other halogens with greater atomic number. Okay. Now moving to the next chemical reaction, that is reaction of halogens with water. How halogens react with water? So normally the reaction is common for chlorine, bromine and iodine, but there is some exception in the case of fluorine. So fluorine react with water and produce oxygen gas. Note down that exception. Fluorine also react with water. They are soluble in water. They will react with water and liberate oxygen gas. And what about the other halogens? So the other halogens, chlorine and bromine. Other halogen, chlorine and bromine, which react with water and produce HX and HOX. So this HX is hydrohalic acid. Okay. So HX is what? Hydrohalic acid. And this HOX is hypohalous acid. HOX is hypohalous acid. This is very important. Sometimes instead of this X, if chlorine or bromine will given plus water, you have to complete the reaction. In that case, please understand halogens like chlorine and bromine, only bromine and chlorine, they will react with water and produce HX and HOX, hydrohalic acid and hypohalous acid. Okay. And what about the reaction of iodine with water? Iodine not spontaneously react with water. That reaction will be very slow. Iodine do not react with water in a spontaneous manner. Okay. And next chemical reaction is reaction with hydrogen. And this is the very common reaction, and this is we know what happened when hydrogen react with a halogen. So always halogens have greater affinity towards hydrogen, but that affinity decreases in the order fluorine, chlorine, bromine and iodine. So the fluorine exhibit greater affinity towards hydrogen. Okay. So here you can see first of all, under this category, reaction with hydrogen, like the previous case, group 16, two properties actually here we will see. One is acidic character and other one is stability of these hydrides. Okay, so halogens will react with hydrogen and form hydrohalic acid, or we can say hydrogen halide is formed. So here comparing this acidic character, we'll think normally HCl is the strong acid because that is the familiar acid to us, but actually acidic character is increases down the group. Acidic character of this hydrides is increases down the group. Okay, increases down. That means HF is the weak acid and HI is the strongest acid. Okay, so hydrofluoric acid, which is less acidic, but this HI is more strongly acidic. So what is the reason? Can be connected with the stability. And what is the order of thermal stability of these hydrides? The thermal stability of hydrides is decreases down the group. Thermal stability decreases, but acidic character is increases. So of course, thermal stability decreases means bond dissociation enthalpy also decreases. So when we reaches to this hydrogen iodide, what happen? Bond dissociation enthalpy will be very less. Iodine hydrogen bond can be cleaved very easily. So H plus can be released fast, and that is why HI is the strongest acid. So this reason behind a strongest acidic character and stability both can be explained with the help of this bond dissociation enthalpy. Why acidic character decreases? Bond dissociation enthalpy. Acidic character increases, bond dissociation enthalpy decreases. And why stability decreases? Bond dissociation enthalpy decreases. Okay, so both can be explained with same reason. Now the third one, reaction with oxygen. How halogens react with oxygen? Halogens can react with oxygen. Even though they are electronegative, they can react with oxygen. And first halogen is fluorine. So fluorine combines with oxygen and form only two type of oxide. Fluorine react with oxygen and form only two type of oxide. One already we have learned, OF2, and other one is O2F2. So the two compounds of oxygen and fluorine is OF2 and O2F2. But here only this OF2 is stable. Okay, the only one stable compound of fluorine and oxygen is what? That is OF2. O2F2 is not thermally stable. Okay, and this OF2 and O2F2, how it formed actually? When fluorine reacted with oxygen. So normally when any of the element combines with oxygen, that resulting compound we will call as oxide. But in this case, when it reacts with fluorine and oxygen, that resulting compound is not known as oxides, they are called fluorides. Okay, so OF2 we will call fluoride, and at the same time O2F2 also we will call that as fluoride, because fluorine is more electronegative than oxygen. So we will always say this is fluorides, not oxides. So note down that thing. Now next thing, what about the use of this O2F2? What is the significance of this O2F2? So O2F2 is used to remove this plutonium from the nuclear fuel. In order to remove the plutonium from the nuclear reactor, we will use this O2F2. So this plutonium combines with this O2F2 and can be removed as PuF6. So what is the purpose of using this O2F2? Used to remove plutonium as PuF6 from the nuclear fuel. Okay. And what about the other halogens? We have already learned fluorine can form only two compounds with oxygen. They are called fluorides. And what about other halogens? They can combine with oxygen and form many compounds. So for example, if chlorine combines with oxygen, they will produce 4 stable oxides. Okay, so Cl2O, then ClO2, then Cl2O6 and Cl2O7. And all these 4 oxides, they are highly reactive and ready to explode. At any time they will explode. They are highly reactive. All these oxides of chlorine. And out of these 4 oxides, note down the case of ClO2, which have wide applications. The ClO2 is used as bleaching agent. Okay, it is used in the field of bleaching. So moving to the oxides of next halogen, that is bromine. So bromine will form mainly these 3 type oxides, Br2O, then BrO2 and BrO3. And the speciality of these 3 oxides, they act as good oxidizing agent, but they will exist only at low temperature. These 3 oxides will exist only at low temperature. Just to go through the names, that's enough. Okay. And now iodine. Iodine can form 4 types oxide, I2O4, then I2O5 and I2O7. Sorry, 3 type oxides they'll form. And in which this I2O5 is important, because this I2O5 is used for the estimation of carbon monoxide. What is the significance of I2O5 means? Which is used for the estimation of carbon monoxide. So please go through the oxides which is formed from halogens other than fluorine. So chlorine 4, then Br3 and also iodine 3 oxides. Okay. And next, reaction with metals. So halogens will combine with metals and form metal halides. And metal halides, when metal attaches means we know that it will exhibit ionic character. And what about that order of ionic character? The ionic character follows this order: metal fluoride greater than metal chloride, then metal bromide, and finally metal iodide. Okay. And the speciality is that in the case of this metal halides, if it exhibits higher oxidation state, then that will be covalent in nature. That means in some cases same metal can form metal halide with lower oxidation state and higher oxidation state. For example, here you can see this Sn can form SnCl4 as well as SnCl2, but oxidation state is greater in this SnCl4. So in this compound, this SnCl4, the nature of the compound will be covalent in nature. That means normally metal halides are ionic in nature, but if the same metal can form different halides means compound with higher oxidation state will be covalent in nature. Note down that. Next is reaction with halogens. Is it possible halogens can react with other halogen? Of course, one halogen can combines with other halogen, and like if they combines each other, they will form interhalogen compounds. When halogens combines with other halogen, the resulting compound is known as interhalogen compounds. And mainly they will form interhalogens compounds of these four types: XX dash, then XX3 dash, then XX5 dash, and XXX7 dash. Okay, so please note down. These are the four major types of interhalogen compounds will be formed. Where one condition is there, X should be larger than X dash. Okay, the condition is that X should be larger than X dash. If an halide XX dash is formed, for example, we can consider ICl. ICl is an example for interhalogen compound where iodine, the radius of iodine is greater than chlorine. That's why this compound is exists. Instead of this, we can't write it as CLI. We can't write it as CLI because what? Cl is smaller than iodine. So in an interhalogen compound, X should be greater than, size of X should be greater than X dash. Otherwise, the compound which do not exist. Okay. So note down that thing. And here how these interhalogens are prepared. Interhalogens are prepared simply by the direct combination of halogen. If we need to prepare a compound of chlorine and fluorine, means chlorine and fluorine can be combined directly and the reaction will take place. But nature of the product will depends upon concentration of the reactant and temperature. Okay, interhalogen compounds can be prepared by direct combination of halogens, but the nature of product depends upon the amount of reactant we have taken as well as the temperature, whether it is high or low. So for example, if here we are taken equal amount of chlorine and fluorine, they combines 437 Kelvin and form 2ClF is formed. Here we can't write the product as FCl. We can't write because size of the fluorine is small. Larger atom should come first. Okay. And if we are taken excess amount of fluorine, just to note down this difference, Cl2 compared to the Cl2, fluorine is excess. If excess amount we have taken means also the temperature 537 Kelvin. So we will get 2ClF3. So these are interhalogen, both are interhalogen compound, but they are of different types. This is coming under XX3 dash, but this is XX dash. Okay. And next one, iodine and chlorine. Compound of iodine and chlorine can be prepared. If we are taking equal amount of iodine and chlorine means we will get XX dash type. ICl will be formed. And if we are taken excess, means we will get ICl3. And normally a question comes, why I3Cl? I3Cl is not formed because interhalogen compounds are mainly of four types: XX dash, XX3 dash, XX5 dash, and XX7 dash. Okay, so the compound formation takes place only in that defined composition. And in the case of XX7 dash, the common or the well-known compound is IF7. Okay, so the well-known compound under this category XX7 dash is IF7. So these are major chemical reactions of halogens. So please note down, especially oxidation state, reaction of halogens with water, and how two halogens were combined, they will form interhalogen compound. And please note down the condition, first one should be larger than second one. Okay, so thank you.